Hi there, Mr. Sutton here. I've got the IM3 Chapter 7 Quiz 3 Extra Practice Solutions here on Advanced Triangle Trigonometry.
On this problem, I'm trying to find the area of this triangle to the nearest tenth. Now, since this triangle, I've got a side, another side, and the angle between them, and it's not a right triangle as far as I know, I'm going to go ahead and use the half-sine formula. That's k equals 1/2 AB sine c. So that's going to be 1/2 times 14 times 25, A and B are the two sides there, times the sine of my angle, 41 degrees. And I'll just do the rest on the calculator. So plugging all that in the calculator, I end up with about 114.8. To find the area of this triangle to the nearest tenth, since I've got all three sides, I'm going to use the Heron's formula here. So to get that, I'm going to start with finding the semi-perimeter S. That's half the perimeter, half of A plus B plus C. So in this case, that's half of 32 plus 51 plus 43, which I'll now calculate on my calculator. So plugging all that in, that comes out to about 63. And now I have to use the K formula to find the actual area. That's the square root of S times S minus all three sides. So this formula right here. So I've got the square root of my S value that I just found of 63. And then we have 63 minus A, so 63 minus 32, 63 minus 51, and 63 minus 43. Let's plug all that in on the calculator. So entering all that in carefully off camera and pressing enter now, I end up with approximately 684.6. On this problem, I'm trying to find this missing angle. Since it's not a right triangle, I have to use either law of sines or cosines. And since I've got an angle and a side across from it, that means I'm going to have to use law of sines. So that's sine of A over A equals sine of B over B. So using the angle side pair that we know a little bit more about from my first set here, I've got sine of 112 over 39, the side across from it. And that's going to equal the sine of B, so that's the angle that we want, sine of X, over 41, the side across from it. Now I'm going to have to solve for sine of X before I can solve for X. So let's isolate sine of X. I'll multiply 41 by both sides to do that. So that's 41 times sine of 112 over 39. And at this point, I have to take the inverse sine of all this stuff to get the angle. So here I am on the calculator. I've done second sine to get sine inverse, and then alpha y equals to get that fancy fraction and plug all that stuff into sine inverse. Pressing enter. That comes out to 77.1. So that's my initial answer, and it's definitely a good answer. But the question is this the only answer? When finding angles with law of sines, there's always the possibility that the supplementary angle, the alternate answer, is correct as well. So to find that, we have to do 180 minus this answer. So 180 minus 77.1. And let me use the calculator for that. So just to make sure that I'm getting the correct numbers here. I probably could do it without a calculator, but I already used the calculator, so why not just do it again? So that's 102.9. So the question is, does this fit in the triangle with the angle that's already in there for sure? So 112 plus 102.9, is that less than 180? It is not. It's definitely more than 200, so it's definitely more than 180. What that means is that that's actually not a good answer, so we'll cross that off. And then the only answer is actually just going to be the 77.1. For this problem, we're trying to find a missing angle, and we're not sure whether or not this is a right triangle. We can't be sure about that, so we need to use either law of sines or cosines. Now, since I have all three sides, that means I have to use law of cosines. I don't have an angle and a side across from it that I know. So law of cosines that would help me here, that's cosine of C equals a squared plus b squared minus c squared over 2ab. So we have cosine of x, and then the c value, which I always pick out first, that's going to be the side across from the angle that I want. So here's the angle I'm looking for. Here's the side across from that, this 27. So 27 is our c value. And then a and b are going to be the legs of the angle that I'm looking for. So I've got 25 squared plus 16 squared, or vice versa. It doesn't really matter which one is A versus B. And then we have minus 27 squared. That makes a difference if you get the wrong number there. Now down below we have 2 times the legs, so 2 times 25 times 16. And let me simplify the right side of all this stuff on my calculator now. So plugging all that in with alpha y equals for my fancy fraction and pressing enter to simplify, that comes out to 19 over 100. So that's what the cosine of x equals. To get x itself, I'm going to go back on the calculator and I'm going to take the inverse cosine of this fraction. So second cosine, and then let me cut and paste that in there by up arrowing and pressing enter on that. Close parentheses, press enter. We get 79.0 degrees. And because we used law of cosines rather than sines, this angle is unambiguous. There's no other answer. We know that this is it. On this problem, I'm trying to find a missing angle, and I don't necessarily have a right triangle, but I do have an angle and a side across from it. So I can use law of sines for this one. So sine of A over A equals sine of B over B. So we'll do sine of 17 over 30, and that's going to equal sine of my missing angle here over 53. Let's isolate sine of x before we do anything else. So just multiply by 53. That's 53 sine of 17 over 30. Now to actually get x out of all this, I have to inverse sine all that stuff on the right. So let me use the calculator for this piece. So here we go. I did second sine to get sine inverse and alpha y equals to get my fancy fraction. Plugging all that in, we get 31.1. So that's at least one correct answer. Now, we might also have an alternate answer, the supplement of 31.1, 180 minus 31.1. And this is always an issue with law of sines. Whenever you use it to find an angle, you might always have this other possible answer. So let's see what that comes out to on the calculator. And then we'll see if we can actually fit that in the same triangle as the other angle that's already in there. So this comes out to 148.9 degrees. Now, will 148.9 fit with the 17 degrees that's already in there? Well, if I add those two angles together, I'm going to get 160 something, right? We don't even need the exact answer, but we know that it's less than 180. That's the important piece here. So that means that both 31.1 and 148.9 need to be listed as correct answers. For this problem, I'm looking for a missing side, and I definitely do not have a right triangle. I can tell for sure that I don't. So that means I need either law of sines or cosines. Now, I've got an angle and a side across from it, so that means I can definitely use law of sines here. So we've got sine of A over A equals sine of B over B. And then I'll just use the side and the angle that I know more about for this first one here. It doesn't really matter, but we've got sine of 20 over 15. And then we have sine of 78 degrees over the side across from that, which is the x we're looking for. Now to solve for x, I need to cross multiply. So I have 15 times sine of 78. And then I would have x times sine of 20, but I know I'm just immediately going to divide by 20. So I'll just put the 20 down here in the denominator where it's going to end up anyway. And now I just plug all that into my calculator. So here we go. I used alpha y equals to get my fancy fraction. Press enter on all that stuff. And that is 42.9. Now, although this is law of sines, we used it to find a side, not an angle. So there's no ambiguity here. We know for sure that this is the one and only answer that we need to give. On this problem, I'm trying to find a missing side of a triangle. It's definitely not a right triangle. We've already used up more than 90 here, so we can't use SOHCAHTOA. So that means it's either law of sines or cosines. Now, because I don't have an angle and a side across from each other that I actually know, we don't know the angle that goes with 16 or the angle that goes with 14, that means I've got to use law of cosines. That, and it's a side angle side setup, so that's definitely law of cosines. So there's two laws of cosines, or at least two versions of the same formula. We're going to use the version that starts with c squared equals a squared plus b squared minus 2ab cosine of c. So we can write then x squared equals, and now we have an a and a b. Those are my legs of my angle here. So 14 squared plus 16 squared minus 2 times 14 times 16 times the cosine of this 120. Let me plug all that into the calculator on the right side. So entering all that in there carefully and pressing enter, we end up with, wow, what are the chances? Exactly 676. So be careful. That's what x squared equals. To find x, we have to square root that. So let me go back here, and let me just do second square root. Let me just cut and paste what I just got from my answer there for x squared. Press enter, and that is exactly 26. Nice.